Right now, a single iron atom is doing something bacteria took 2.7 billion years to learn, and it could end the century-long nitrogen catastrophe we never knew we started. But to understand why this matters, go back to a Norwegian fjord in 1913. Fritz Haber and Haber-Bosch forced nitrogen and hydrogen together and accidentally removed the ceiling on human population growth. That process now feeds 4 billion people. But it also unleashed a nitrogen flood we never learned to contain, bleeding from every cornfield, straight into the rivers below. Think of it as a nitrogen highway with no toll booths. Fertilizer made in Louisiana, consumed in Iowa, dumped into the Mississippi, paying a price to no one except the ocean, dying at the end. Here is the brutal arithmetic: $72 billion lost annually to nitrate water treatment, a greenhouse gas legacy that rivals aviation's entire climate footprint, and 210 million Americans drinking contaminated source water. That's when everything changed. In 2020, Huaben Zhang at the University of Adelaide published numbers the field had never seen. A tiny iron-nitrogen-carbon reactor converting drain water nitrate to ammonia at over 90% efficiency. The secret was architecture at the invisible scale. A single iron atom, caged in nitrogen and carbon, physically blocks the easy chemical exit, forcing electrons to build ammonia instead of wasting themselves on hydrogen. And here's the biological echo that stops researchers cold. That iron in nitrogen-carbon geometry is nearly identical to the nitrogenase enzyme bacteria evolved 2.7 billion years ago. Nature and engineering arrived at the same answer. For families like the Bishops of Illinois, 800 acres of tile-drained corn since the 1980s, this technology means their drainage ditch stops being a liability and starts being a fertilizer factory. The asset was always there, and the stakes kept rising. China has filed the majority of global patents on this exact technology, building the same asymmetric IP position it built in solar panels a decade before Western industries noticed. The window may be 36 months. By 2030, if solar-style cost curves hold, electrochemical ammonia recovery reaches $400 per metric ton, cost parity with Haber-Bosch, zero carbon footprint, powered by sunlight. The third act of the nitrogen story begins. Haber opened the loop in 1913. We've been bleeding nitrogen ever since. This iron atom, smaller than imagination, may finally close it. Subscribe if you don't want to miss the next breakthrough. We cover emerging tech most people won't hear about for years.